Okay, so we're back. Middle check. Background music. Nice. So, this is probably going to be a not so long stream. But we'll see how it goes. So, what we actually want to do is to test those comments that we implemented the other day to see if they work as expected. Because I guess at the latest day I was able to implement those, but I did not, so make package respective platform, I did not test them. So that's what we are going to do right now. So we are here in AMD 64 ISO, and we're going to test these comments here. So let's see how the hell do we do this. Yeah, so we clean the platform here. And wait a minute, why? Docker run, okay. We prepare this thing. So we prepare the platform so that we can build the stuff. We build the thing. Okay. And this is going to take a while. So you can ask questions in the chat if you want to. And once this has been built, I'm going to package it, and we will see if if this works as expected. And I'm not sure. So maybe what we want to be doing in the great scheme of things is to the next step. It's going to be packaging Rescap, because building Rescap and packaging it so that we can use it from within Rescatux. So I would like to actually test this thing without too much hassle. And yeah, maybe we could automate testing of the ISOs. I'm not sure about that because I currently do it manually. But if we could have some make run platform thing on that, that would be nicer, because yeah. So for the next video, let's think about building Rescap, adding run comments to run command to make files so that we can run KVM and simulate several scenarios. Not sure about that. Not sure how this is going to be playing out, but that's what we're going to do. So let's remove this thing so that you can see what's going on here. So this build is this is building the live build thing. So it's building everything, and yeah, this and that, and yeah. By the way, I'm going to open the mail on the second screen that you cannot see, so that you know, you can so that I can check. So this is a live CD. You can see that we have a lot of Xorg packages, so that we can use the Xorg in the live CD. Oh my God, this wasn't supposed to be opened on the right, although I don't care too much. Okay, so we have some feedback regarding supergroup disk. Supergroup disk. I mean, it's not actually supergroup disk, but this might be interesting to take a look at. Oh my God. Oh my God, this is too black. Let's do the toy problem. So this is Shahir, and this is okay. Let's give here. Oh, this is we are 7 minutes onto the video. 7-8 minutes onto the video. 7 minutes or 8 minutes onto this live stream. That's the live stream. That way I don't have. Sorry about that. So this guy asked me the problem which I wanted to ask you was about regarding the multi-boot method to use supergroup as a Bentoy alternative, but I figured they both work the same way. It's not the same way, but yeah, I have done some research on this matter that is that a better method can be derived to multi-boot ISOs, which is better than what supergroup and Bentoy and other tools do. I have made a blog regarding using my finding and solutions. The blog is here. So it says it's no longer related to supergroup disk. So yeah, we're going to say what as players cove. What is this supposed to be? Cove. I mean, it's cave, it's not cove. This is probably wait. Seriously? Is this something? Oh, so it's a cave. I mean, maybe not a cave inside some water, so it's like this thing. Yeah. That's interesting. So I would say display as player's cave, but it's cove, because a cove is this thing here, something like a golf. Let me check how the hell this is Spanish. Ensenada. Ah, cala. Yeah, cala. That makes sense. La cala de es players. Okay. Yeah, let's focus on the problem, because this might be interesting regarding multi-boot and so on. And yeah, what the hell? Okay, let's read. Let's read. I mean, there's a lot of text, but usually when there's a lot of text, you can learn, and that's what we are going to do. 1 second that I turn down the volume of my background music. So he says, my state for Bentoy, the popular USB multiple tool, started this year when I was working on Lufus. Okay, what the hell is Lufus? Beta release. Lufus is a physical drive imaging and formatting intuitive written in Python inspired by Rufus on Windows, with the goal of delivering a greater experience for Linux users. While core functionality has been implemented, the project is still under active development. Users should expect bugs, complete features, and ongoing structures. Okay, so this is like Bentoy thing, like Rufus stuff. In the what's the other one? The Balena Etcher. That's the only one that I like, because it's just selecting the ISO, then you put it on the USB, and then you flash. It's rather easy to use. Okay, so his estate for Bentoy started this year when he was working on Lufus. Okay, so we wanted to add a multi-boot feature similar to Bentoy to Lufus as well, and we were brainstorming on various ways in which we can achieve this. One of the ideas was that we can just use Bentoy itself, but due to it being GPL, oh my god, licenses, Bentoy being GPL, Lufus being MIT, we avoided it. Almost every multi-boot tool uses group O anyway, so there isn't really any alternative anyways. There's this stupid tool malus.sh, which is a clean room as a service. Okay. So it's kind of a joke, but it works. So you can recreate any open source project from scratch. I mean, if the project is quite big, it takes long, apparently. But this could be this is the main idea, is that you can take something that it's open source and turn it in non-open source. So it can be primitive code, but this in theory could also be used in order to convert, a GPL license code into a MIT license code. There are some, some people that don't think that's right, that's not legal or whatever, that you're not respected the license, but yeah, you could explore that. So let's keep reading on. While researching on Bentoy and how it works, I came to know that Bentoy uses hooks or custom configuration for every single distribution. That's right. It's supposed to enable multi-boot. This is a very nasty way to program stuff. That's why I pushed liveid, So liveid, that's something that I pushed. I mean, it has not taken off. It has not taken off. But the idea is that every distro is going to implement what it needs in order to be able to be booted from an ISO. So it's a loopback boot. Okay. In the but we're going to keep reading on and see what this goes on, how this goes on. Okay, so this is a very nasty way to program staff, mainly because it is very tiresome and redundant for developers as they need to update the configuration in case of major updates to enable multi-boot. But we can't blame the Bentoy devs at all. The problem lies at the core of every distribution and how they implement their boot processes. On paper, it might seem that they must have at least some standard for this, but in reality, it is rarely followed. The UEFI standards tell where the boot firmware should be located, but inside the ISO, it can be anywhere the devs put it, and as Bentoy boots from this very ISO, it becomes a problem to boot using a universal configuration. Not to mention that some distros don't even use EFI. Yeah, that's the old ones, or the ones that want to be. Look at that. Technical. That's not right. That's technical. So some distros don't even use EFI among other technical limitations. So the Bentoy devs have to hardcode the paths in the configuration for every distro. Okay. Okay, but how to fix this? My first intuition to solve this and introduce new uniform methods was, can a bootloader not just recursively look for the files it needs? Yeah, that's right. That's what I solved with liveid. The first problem with this is that there can be multiple files of the same name at different locations. So how will the bootloader use the correct file? Secondly, even if the bootloader currently identifies the firmware and boots the kernel cannot automatically know where the root file system is. Look at that. Even if the bootloader currently identifies the firmware and boots the kernel cannot automatically know where the root file system is unless it's explicitly told. And that's why we have liveid, where each one of the where the hell is this? Each one of the ISOs it's where the hell is this? Where's the liveid example? Why isn't there any example of how this is supposed to be liveid? Maybe in here. Okay, let me check. Maybe here we have a liveid thing. Here it is. So basically, what happens with the liveid idea is that we save onto the ISO this file here. Okay, so you've got the liveid. There's an only single directory, and then you have a UID, and this is going to be found in the ISO. So there's no other way. You cannot fail that. So this might be in an ISO, this might be in a hard disk directory. We don't care, you know. If you find this file, you are in the right place. So this is where the the ISO needs to have this default CFG that points to this, and we are done. We can find this thing properly. Okay. Yeah. Secondly, yeah. So that's it. Secondly, even if the bootloader currently identifies the firmware and boots the kernel cannot automatically know where the root file system is unless explicitly told. Liveid. It tries to find a CD-ROM, but seems that won't exist. It would crash and cause a kernel panic. Lastly, there is also driver issues for different file system, which Bentoy solves by carrying this. Yeah, I mean, the driver issues, I just use group 2 and that's it. But yeah, it's true. Bentoy solves by carrying its own drivers. Okay, but how to actually fix this? The problem is with distributions having different path structure, right? So why not introduce a new standard which will implement uniformity? Well, I am pretty sure people have tried this before and it hasn't worked. Why, you ask? Here the popular XCD 925 will tell you that you have 14 standards, someone makes something universal, and you have 15. So I'm going to tell you about liveid. So liveid, I sent some emails to the SUSE guys, to Red Hat guys, the guys that made the tools in order to make the liveIDs, because this was mostly aimed at liveIDs. And what do they told me? You have to make a contribution. So I had to learn how to use what's the Dracut. I had to learn how to use Dracut, so that Dracut had support for live. Let's do something like this. Okay, so it's like a C. Okay, so yeah. So instead of using mpk initrd, so the Red Hat liveid, SUSE, and so on, use Dracut. Okay, so it's explaining here how it works and so on. And if we change this into English, you have it here. So basically, you create the kernel, the init, RAM, fs, and so on, so that you have a liveid. I mean, it's only one part of making a liveid, but so the thing is that the reason why this didn't take off is because I didn't have time at the time in order to implement, in order to go to every one of the systems. I only implemented it in the Debian Live, and I wasn't able to push it into upstream Debian Live, you know. And yeah, I mean Debian Live, I mean live build, but yeah, you get the idea. The Debian Live system. So, and I tried the second time to push it, but then I was busy and I couldn't resume it. So I'm pretty look, there's more text, so like we are on a half page, so I want to see how this goes on. Okay, is there even a solution? Well, for starters, instead of creating a new standard that it's almost certain to not be followed, that seems like liveid, we can propose additions to existing standards and then implement those standards into different distros. Turns out that there is already a specification standard which aims to achieve standardized another stuff, that this is not well written. Standardized directory structure and format called URIP bootloader specification, but it lacks the stuff needed for our purpose. As the BLS standard is for normal partition and not for ISOs, we have to add 2 new keys to the BLS standard to support booting from ISOs. ISO file. This key tells bootloader the path to the Linux and initrd relative to the ISO, so that bootloader can actually look inside the ISO for the kernel files instead of trying to find it in the physical disk. Okay, so regarding all this stuff, we have liveid. That liveid helps finding the, helps finding. This is more or less the idea. No, not this one. So loopback solution is like this. So loopback solution is that you put the ISO path, and then wait a minute, where the hell is this? Where the hell is this? So basically, what it's related with this way of working is, the loopback thing, which it's archive. Okay, it's in my wiki, but it's archive. So we're going to take a look at that. The idea is that you have every live CD should have a boot and a /boot /group /loopback.cfg with all of the stuff that it needs to be booted, because it's not always the kernel and the init rd, but we have also more stuff there, and the distribution knows what it needs to be able to boot, and it knows which are the options that it needs to be booted, because you can have a live CD with two boot options, but with more boot options. So supergroup this loopback wiki. So look at that. Is this myself? I don't know. So this is supposed to be coming from the wiki, which, yeah. Here it is, loopback. So this doesn't work right now because, that's too much work to update MediaWiki. So if you take a look at the past, so maybe, I don't know, here 2021, is this going to work as expected? I'm not sure. Yeah. So this is what, let's put this link in the chat, so that, because otherwise it's a long link. So look back is just a group.cfg that's designed to be used to boot a live distribution from an ISO file on a file system rather than an actual physical CD. So the problem, so this is mostly what these guys want to tackle. Okay, so we have already discussed about this back in the past. So if you take a look at the archive stuff, there are captures from 2019. Okay, so this is quite old, but it's the same problem. So the problem is that to actually boot such a distribution, you need to know the path to the kernel init IRE within the ISO, the particular kernel parameter that this distribution uses to specify the path to the ISO, and any other kernel parameters relevant to the distribution. Even knowing that, when you boot the ISO, you don't get the menu and options you get when booting the CD-ROM. With the loopback.cfg, you get the full menu of options at boot and don't have to worry about differences between distributions. This is the right way of implementing this. Okay, this is the right way. Loopback.cfg, and if you have several, so loopback.cfg is being able to boot from to boot an ISO file from a file system. A liveid, what does is, if you have several USB devices, okay, if you have several USB devices and they are not the same USB, they are not the same ISO, it's going to work as expected, because what we are actually doing is giving each one of them an UUID thanks to the liveid, which is calling an UUID. Okay, so let's go back to the thing. Okay, so it says the BLS file. So he's proposing to add two new keys: ISO file This key tells bootloader the path to the Linux and init.rd relative to the ISO, so the bootloader can actually look inside the ISO for the kernel files instead of trying to find in the physical disk. ISO type, as different distros use different hooks to find files. Dracat, Casper, yeah, that's the Dracat we were talking before. Casper was for Ubuntu. This is, the distro just specify it in this key. That's not good enough. You should implement loopback.cfg and what's the thing? Loopback.cfg, liveid. Okay, I mean you can implement something similar to loopback, like saying, okay, let's implement something that defines what needs to be in the USB, how the boot menu is, but yeah, and then you parse it, and it doesn't need to be a group file, so you have another standard. Okay, so the new BLSF comp should look like this if we follow example from the official UIPI.1 documentation. So, title, sort key, machine ID. Okay, so I'm not sure about this. Version. Okay. ISO files, ISOs. So here you can see how you are coding a path to a folder that has ISOs in it. So it's a bit, you're losing the thing. ISO type Dracat options these things, so you are forcing some kind of options. And then you've got here Linux, which is the Linux kernel, init.rd, and then some extra stuff. Okay, so let's keep reading on. So now when the bootloader runs and reads the keys, it can loop back. Look at that, it can loop back. So now when the bootloader runs and reads the keys, it can loop back the ISO file and remap that as the root path for executing stuff. This removes the need for hard-coded paths of firmware for each and every distro, as done in tools like Bentoy. As now the distro itself tells the bootloader where to find them. It's also backwards compatible with older bootloaders. So what's next? I think I have to rename the ISO. So let's rename the live stream so that where the hell do I edit the video? Let me edit the video just right. Discussion about booting Linux from a loopback from a file system. And wait a minute. Booting Linux ISOs from a live system. Port Debian. Yeah, and let's end. Yeah, I mean, I don't know. Let's go back to the video so that I can see the video while it plays, and I can see how many people are watching and so on. So, what's next? The problem with using BLS for now is that not every distro supports the BLS standard yet. So even after new keys are added, we will have to slowly make other distros support it. So regarding adding the new keys, that in itself is painstakingly hard and time consuming to do. I have made a thread. Oh, where the hell is this? I need to read this proposal thing. Let me open it here. 0 comments. That's very okay. Regarding adding the new keys. Wait, I am loading a bit, but 3 weeks ago. Yeah, maybe they don't want to implement that. I don't know. Okay, let's keep reading on. Regarding adding the new keys, that in itself is painstakingly hard and time-consuming to do. I have made a thread in the official GitHub discussion for the new keys proposals, but it hasn't seen any response for almost a month. Yeah, that's right. For almost a month at the time of this writing. This method is obviously only supports Linux distros, and for other OS, just as Windows or Mac OS, hardened configs will still be needed, I assume. Yeah, actually, with loopback.cfg, you could, in theory, yeah, if group supports booting Windows or, I mean, if Windows or Mac OS know how to boot themselves from ISO file, which I don't think they do, you could implement it from here, okay? Regarding the type 2 entries, this is not right. Regarding the type 2 entries unify kernel images, UKIs, yeah, it will be useless for this method since it compiles the command line parameters to binary and will require the type 1 conf anyways. Yeah, this unify kernel images that has everything in one makes things simpler, but at the same time it makes the stuff more complex. Okay, so 6th of June. Okay, so this is quite recent. So this is like when he sent me the mail. So this is from today, apparently. So keep in mind that this is experimental thought, and how we can improve and unify the process by deduction and reasoning can be wrong at times. As I am not a professional system level programmer, Bento is a good tool right now because it works, and I appreciate the hard work of every single developer. I am open to any feedback or advice you may have for me regarding which you can email at. That's the email that I have sent him, and yeah, I have it. Let me double check that it has been sent. Yeah. So hopefully he gets it and he can read, he can watch all of this. So I'm going to check just quick this thing here. Okay, so this has built. So I'm going to keep replying to this question regarding booting Linux ISOs from the file system. So actually, I actually want to duplicate this thing, and I'm going to edit the video again. So future discussion about the future of booting Linux ISOs from a file system in the Rescatux, and I'm going to put here like Rescatux development 2026 episode 26 23 is like this. It's episode 23. Wait, Rescatux Dev. Rescatux Dev. Oh my god, it's discussion about future from file system. Let's abbreviate the thing here and there so that. Wait a minute. I haven't used the right thumbnail. This is supposed to be episode 23, so let me update that too. and we should be good to go. It takes a while because it's updating the image. So in any case, where the hell are you? So let me package this thing to see if it works as expected, because we have already done make build, so now we're going to do make package. Okay, and if we go back to the video, let me see, that's it. If we go back to what we were discussing, okay, so this has been packaged and I think it has worked. Okay, so what I want to do right now is to explain a bit more how to do this thing, how all of this works, because this has already worked. This works. There's some so where the hell do I write this down? So I should have, so this is like 23, isn't it? This is episode 23. So let me do like episode 23, and this is like boot Linux is from file system. Okay, so let's open it from the bottom, and boot Linux ISOs from file system. So we have, let me explain what we have done here. So we have the thing. Okay, so we have the thing that it's our first problem is how does the kernel find the device? So finding the ISO file system, finding the file system that stores the ISO file. So this is the problem number one. This is problem number one. Okay, solution: identify the ISO. Identify the ISO. How the hell was this thing? Find the file that stores the ISO file. I think this is not right. Finding the file system that stores the USB device. So, and then there's this finding the file system that stores the ISO file, and then there's using the right boot parameters to the kernel for the live system to boot. Because now I'm finding out that the thing about so the device, thanks to define the device thanks to a new ID based on file. In other words, live ID. Okay, In the liveid, let's find out the URL. So liveid is in here, and apparently I have an issue that probably is fine. In other words, liveid. Okay. So basically, what you have here is a let me check where the hell do I have this thing. So if you take a look at the Rescatux releases, which I should have somewhere, like here, yeah. So if you take a look at this, so explore, so Rescatux 074. Okay, now we mount. Hi, Unreal Dancing. Are you this guy? Where is the hell is the URL? Are you this guy by any chance? S player, or maybe someone from, you know, yeah, from the open code videos, because my memory is not perfect. So basically, you can boot an ISO thanks to this command here. You can mount it, loop mount it. Okay, so the idea is that you do like this, and now we can open it. So let me just do this thing here. So if we explore the thing here, you can find all of this. So this distro implements liveid, and you're going to find it here. So we've got liveid, and you've got all of this, which the last one is a file. So if you go here, you can see liveid live. Wait a minute, it's capital letter so that it's compatible with, you know, MS-DOS and so on. So yeah. Are you in cybersecurity? Well, I am not. So yeah, this is so found at the root of the ISO. So this is what you find at the root of the ISO. You find the UUID, okay? In the so liveid. So you've got you've got some stuff. So it's liveid at distro liveid generation. So you need Dracat, Casper, MKinit RD live build to generate this live ID file. Okay. Then live ID at init.rd. Init.rd. Is this something that I actually did or not? That's a very good question. You know, you need this is not right. So you need Okay, wait a minute, please. Live. Okay, so we are back. So we're saying that you need liveid, which is you know, live cd build tools to generate these liveid files. Okay, live cd generation. Then you need this at init.rd, I think. And no, that's not right. So in order to find, init.rd, you need drag and generate files. So this is
init RD scripts in general. So live build, this is live boot. To search for this file, This one I'm not sure about this, you know. Not sure about this. Wait, where the hell are we? Let's make this bigger. So I'm not sure about this one here. Okay, so you've got the file system where you find the file system that stores the USB device. You use this UID. Okay, and so related to this is how do you use the right boot parameters for the live system to boot, and that's where you use so you use boot group loopback.cfg, which states several stuff, which is states which kernel to boot with which UID, which with init RD, with which boot parameters. Okay, how many ways of booting, which is several boot entries. Okay, and by the way, example of all of this is Ubuntu no, it's Rescatux 074, which has all of this. So you use boot group loopback.cfg that states which ways of bootings, several boot entries, and then you've got which kernel to boot, which init RD, okay, which boot parameters, okay. So that's what I have in here. But you have the loopback.cfg, okay, and so this is like the first place is you need live cd build tools to generate loopback.cfg. So this is loopback.cfg generation, let's say, and then you have boot from loopback. So this is done from supergroup disk and can be easily adapted to any group 2 because that's what it is. So how this is done? Well, we can take a look at supergroup whatever, supergroup. So I can take a look at the current branch, maybe the latest tag. Michelle, so 2020, let's use the latest tag so that this is much easier. Conversion to 260 S4. Wait. That's interesting. So I don't have the main branch. I have a divergence here. So the main branch has, the main branch has some installation instructions, and here in this tag, I bump into 2.06. Yeah, but other than that, it's basically the same thing. But yeah, it doesn't matter. Let's browse the files here in this tag, because what we want to explain is what the hell do we use in order to so look at that. Look at that. Supergroup this has its own loopback. Okay. Which we don't support because supergroup to disk is made to boot some stuff. So you have the same loopback. We ignore it. So here we have the auto ISO in the, yeah, if I'm not mistaken, the thing is done in the auto ISO thing. Okay, and this is probably more, this is more loopback ISO entry. This is more difficult than it should be, because that's, yeah, that's how this should be. Okay, so this is it. So basically, um, basically the way of implementing this thing is something similar. So the nice thing about the nice thing, does this work at all? I don't think so. CFG is going to be something from Nagios. I'm not sure what to use here. Wait a moment, please. Okay, so let's keep going on a bit more in the, yeah, we will see how this goes. So this is the code. Let's do maybe bash. It's going to highlight this purplely, right? So this is the every distro code from supergroup to disk. Okay, and this is like a hard-coded distro, so that you can get the idea of what this is about. Okay, so menu entry. Where the hell was this? Yeah, this return thing doesn't match here, isn't it? So hard-coded distro thing. So this is so that you can see the example. So this is like yeah, I mean real def and that. So this is like Rescatux 0 from ISO. This is like something like that. And then the device and so on. So the device is like, I don't know, page the 1. So you could have this thing here, and then you've got the ISO. So it's like ISO's Rescatux 074 ISO. So this is the ISO path. Okay, so so in the CFG path is just where the hell is the ISO. So this usually is root group loopback.cfg. You know what I mean? So basically all of this doesn't need to be additional parameters. So this would be something like this. So I export the ISO path, which I get from somewhere else. So it's like something like ISO path equals this thing here. Wait a minute. Yeah, so ISO path. Yeah, we actually want to export the ISO path. Yeah, maybe we can do this without too much of this, but I don't know. So the idea is something like that. So ISO path is safe. It's the second one. It's saved here, and then we export it. So we export it so that we can config file this loopback.cfg, and this ISO path goes into loopback.cfg, which is going to be using it. Okay. So loopback.cfg generation, boot loopback.cfg, and then loopback and this and that, and yeah. So this is more or less how this looks like in order to hard disk the thing. So it's, you've got the loopback.cfg generation, you've got boot onto loopback from main menu, from boot onto loopback.cfg from main menu, let's say main menu, and then it's then what we have here is boot from loopback.cfg itself. So what we want to be showing here is how a loopback.cfg would look like. So there's the duplicated code way, and there's the smart way. So the duplicate code is just copying that it's in whatever is a group, which is not what we do in Rescatux. So in Rescatux, we already have this boot group loopback.cfg, and what we do is this thing, we source the group.cfg, which is in here. So you can see how we've got isopath in here. So basically, let's use this thing, which I think it's going to be much better than what we have. Duplicate way is this thing here, and the smart way is, so the duplicate way, boot group loopback.cfg would be like this. In the smart way is the other way around, which is this is group.cfg. In the boot group loopback.cfg is just going to you know, let's say this is bash, even if it's not bash. So we could do something like this so that we have some colors around here. And yeah, where the hell is this? Yeah. Okay, so loopback.cfg is what we have seen. Let me close this thing. It's what we have seen in here. Loopback.cfg, which is source, the other one, and once the other one has the ISO path, you are done. So basically what's this stream about? Strawberry Kitten. So this was originally a stream about developing Rescatux, but right now it's about discussing about boot looping from ISOs. You know, live CDs, Linux live CDs. Yeah. So basically, the group script must use ISO path variable accordingly. Okay, that's how it works. So we have done how to find the file system that stores the USB. So you've got the UID. This is first part. So you have to generate the file. You have to read it from the init.rd, I think. In order to boot the stuff, you need to know which kernel, init.rd, and boot parameters you generate. Loopback.cfg. You can find this file in order to you didn't have to retract the message Strawberry Kitten. You have to boot onto, this is the way of finding the loopback.cfg in order to boot into it, and this is how group would boot from loopback.cfg into the into the kernel and so on. You can say that's very old kernel, but that's because I have to have frozen a bit Rescatux development. Then finally we have finding the file system that stores the ISO file in the this is also done thanks to this is also done. It's okay. So find ISO init RD parameter. So there are different ways of doing this, but it's similar to liveid find ISO init RD parameter. So liveid, which is an init RD generator from Debian livebuild, Debian liveid find ISO parameter. So basically, find ISO, it's a kernel parameter. So the kernel receives something like this thing here, which is, you know, Rescatux 074 ISO, which is passed to init.rd, and then init.rd searches for the ISO file in each one of the system file systems. That's implemented right now in this is implemented right now in livebuild. In the livebuild, Debian livebuild, they have a salsa thing. So salsa Debian livebuild. Here it is, because they work in livebuild thing. Okay. So I'm not sure if I'm going to remember what the hell is this. This is, but if you search in here, you can find ISO should be. So you can see here how we have appended find ISO in here. In the, if we go back to liveid, wait a minute, liveid, you will find this thing. So this is the 998.070 line on, and this is where it starts to work on all of these. You can see how it, if it finds the ISO, it boots it, it finds it, and then it extracts the whatever it has inside of it. In the my fork of this also has liveid on it, so that we can find this thing much better. We can match the liveid thing. I think this is the doubt that I have. Where the hell is this? Not sure about this. So this is how I implemented all of this that this guy wanted to do. Let me unmount the ISO here. Yeah. So sudo unmount this thing here. Oh my god, no it doesn't. Okay, yeah, I have this opened. Hopefully this is good enough. So yeah, this is it. So as I was saying, this is my response to all of this, and regarding the you know, what we were doing with development notes. We were trying to those comments seems to run nice. but we have not tested the ISO. Tested the generated ISO. So yeah, so I'm going to edit the video for the last time, and I'm going to remove the Rescatux part. No, I'm going to keep it. I discuss about how liveid and loopback.cfg should be the backbone for implementing bootable ISOs for Linux, for new Linux live CDs, and that's it. And so we are going to end the stream. Thank you very much for watching. Bye.